Isaac Newton and the Gravity of Spirit. How Positive Thinking Forges Order from Chaos. Introduction. The enduring relevance of Newton in our age of crisis. In the tumultuous landscape of 21st century America, marked by political polarization, pandemic recovery, climate emergencies, and technological disruption, we find ourselves searching for psychological anchors. We turn to mindfulness apps, therapeutic practices, and self-help methodologies, seeking internal stability against external chaos. Yet we often overlook that history's most profound demonstration of the human mind's capacity to create order from disorder emerged not from a modern therapist's office, but from the quiet study of a 17th century English natural philosopher. Isaac Newton represents far more than the caricature of the apple-bonked genius that permeates popular culture. He stands as perhaps history's most compelling case study in what we might now term positive thinking, not in the simplistic sense of mere optimism, but as the fundamental cognitive orientation that discerns pattern where others see randomness, identifies opportunity where others see obstacle, and maintains creative momentum when circumstances would logically dictate despair. In an era strikingly parallel to our own, defined by political upheaval, pandemic disease, and intellectual revolution, Newton's mindset didn't simply produce mathematical breakthroughs. It modeled a way of being that transformed how humanity perceives its place in the cosmos. The scientific revolution of Newton's lifetime represented more than accumulated discoveries. It constituted a psychological transformation of Western civilization. Where medieval minds saw a world governed by divine caprice or magical forces, Newton and his contemporaries began seeing a universe operating according to comprehensible mathematical principles. This shift required not just intelligence, but a particular mental disposition, the conviction that chaos was merely order waiting to be understood, that complexity could be reduced to elegant simplicity, that the human mind, despite its limitations, could comprehend the universe's deepest workings. Newton's England was a nation in perpetual crisis. Born in 1642, the year Civil War erupted between royalists and parliamentarians, he lived through regicide, republic, restoration, revolution, and repeated plague outbreaks that decimated London's population. The 30 Years' War ravaged continental Europe, religious conflicts tore communities apart, and superstition often trumped reason in public life. Against this backdrop of uncertainty, Newton's intellectual achievements appear almost miraculous, unless we understand them as the product of a mind determined to find coherence amid the tumult. This essay argues that what we anachronistically call positive thinking was the essential psychological infrastructure underlying Newton's revolutionary contributions. His ability to transform personal trauma, professional setbacks, and historical catastrophes into creative fuel reveals a pattern of cognitive resilience with profound implications for our contemporary struggles. By examining Newton's life and work through this lens, we discover not just the history of science, but a manual for mental survival in disordered times. Early years, forging light from darkness. Isaac Newton entered the world as a physical embodiment of his nation's fragility. Born prematurely on Christmas Day, 1642 in Woolsthorpe, Lincolnshire, he was so small, his mother Hannah later recalled, that he could have fit inside a quart pot. His father, also named Isaac, had died 3 months earlier, leaving the infant to inherit both his name and the modest family farm. The England of Newton's birth was convulsed by civil war, with King Charles I and Parliament hurtling toward armed conflict that would culminate in the monarch's execution 7 years later. Newton's formal education began at the King's School in Grantham, where he initially struggled academically, ranking near the bottom of his class. The turning point came, according to legend, when a schoolyard bully kicked him in the stomach, provoking Newton not to retaliation but to academic domination. He bested his tormentor not physically but intellectually, rising to become the school's top student through sheer determination. This pattern of channeling adversity into achievement would become a lifelong characteristic. In 1661, Newton entered Trinity College, Cambridge, as a subsizar, a poor student who earned his keep by performing menial tasks for wealthier classmates. The Cambridge of this era remained steeped in Aristotelian philosophy, teaching a universe of qualitative distinctions, natural places, and teleological purposes. Yet Newton's notebooks reveal a mind already straining against these constraints, already asking the revolutionary questions that would define his career. Despite his humble status and the intellectual conservatism of his environment, he maintained what we might now call a growth mindset, the conviction that his current circumstances did not determine his intellectual destiny. The psychological pattern established in Newton's formative years reveals a consistent theme: the transformation of limitation into advantage. His premature birth became evidence of his special resilience. His abandonment fostered self-reliance. His academic struggles fueled determination. His servile status at Cambridge sharpened his independence from conventional thinking. At each stage, Newton demonstrated the core principle of positive cognition, the interpretation of circumstance not as fixed reality, but as malleable material for creative response. The Plague Years, catastrophe as creative crucible. In 1665, as Newton completed his undergraduate studies, bubonic plague returned to England with terrifying virulence. The outbreak had begun in London the previous year, but by summer 1665, deaths were mounting exponentially, reaching over 7,000 per week by September. Cambridge University responded as institutions have throughout history during pandemics. It closed its doors and sent students home to avoid infection. Newton returned to Woolsthorpe in retreat from what seemed like biblical punishment. For most, these plague years represented suspended animation, an interruption of normal life, education, and career advancement. For Newton, they became the most creatively fertile period of his life. Isolated in the Lincolnshire countryside, free from academic obligations and conventional curricula, his mind embarked on what would later be termed his Annus Mirabilis, or Year of Wonders. Between 1665 and 1666, while London succumbed to disease and fire, Newton laid the foundations for calculus, formulated his theory of colors, developed the binomial theorem, and began his work on universal gravitation. The famous apple story, whether literally true or apocryphal, perfectly captures the psychological dynamic at work. According to Newton's later recollection to William Stukeley, the sight of an apple falling in his Woolsthorpe garden prompted him to wonder why it fell perpendicularly toward Earth's center. Where others saw simple fruit falling from a tree, Newton saw a question about the universe's fundamental ordering. Where pandemic conditions might have justified despair or mental paralysis, Newton perceived opportunity for concentrated intellectual exploration. Newton's optical experiments during this period reveal the same cognitive pattern. Working in a darkened room with a prism, he demonstrated that white light comprises the colors of the spectrum, overturning 2 millennia of Aristotelian theory that viewed colors as modifications of light. This breakthrough required not just experimental skill, but a mental willingness to see what tradition said shouldn't be there, to trust observation over authority, to find complexity in apparent simplicity, and simplicity in apparent complexity. The mathematical work Newton undertook during the plague years similarly reflects a mind determined to find order in apparent disorder. His development of what he called the method of flux ions, now known as calculus, provided tools for describing continuous change, for finding the predictable patterns underlying nature's apparent caprice. Where a less constructive mindset might have seen only pandemic chaos, Newton saw mathematical regularity waiting to be discovered. This period offers a powerful historical lesson in what contemporary psychology might call post-traumatic growth, the phenomenon whereby individuals not only recover from adversity, but experience creative expansion because of it. Newton's plague year breakthroughs illustrate how catastrophic circumstances can become creative crucibles when met with the proper mental framework. His isolation became focus. His removal from academic community became freedom from conventional thinking. The generalized fear of his historical moment became sharpened concentration on fundamental questions. The psychological stance Newton adopted during the plague years represents positive thinking in its most potent form, not the denial of difficulty, but the transformation of difficulty into opportunity. He didn't ignore the pandemic's reality. He simply refused to let that reality dictate the boundaries of his intellectual activity. In doing so, he modeled how crisis can become the unexpected catalyst for revolutionary insight. The search for universal order. Mathematics as cognitive framework. Newton's most enduring contribution to human thought rests not in any single discovery, but in his comprehensive vision of a universe governed by universal mathematical laws. This vision required more than intelligence. It demanded a particular cognitive orientation, one that assumed order, sought harmony, and believed in the fundamental comprehensibility of nature. The core of Newton's scientific achievement appears in his Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, published in 1687. In this monumental work, he demonstrated that the same force that causes an apple to fall on Earth governs the moon's orbit around Earth and the planet's orbits around the sun. This unification of celestial and terrestrial mechanics didn't merely solve specific scientific problems. It offered humanity a new psychological relationship to the cosmos, one based on predictable regularity rather than mysterious intervention. That Newton's gravitational theory represents perhaps history's most spectacular example of pattern recognition. Where others saw separate phenomena, falling objects, lunar orbits, planetary motions, Newton discerned a single principle operating throughout the universe. This cognitive leap required what we might now call a growth mindset in its most expansive form. The conviction that apparent complexity reduces to underlying simplicity, that the human mind can discern this simplicity, and that mathematical language provides the key to decoding it. The psychological dimensions of Newton's achievement become clearer when we contrast his approach with earlier cosmological views. Medieval and Renaissance thinkers typically regarded the heavens as fundamentally different from Earth, composed of different substances, operating according to different principles, and moved by divine or angelic agency. This view reflected a psychological acceptance of separation and mystery. Newton's unification of heaven and earth through universal gravitation reflected instead a psychology of connection and comprehensibility. That Newton's mathematical method itself embodies principles we might associate with positive cognition. Mathematics, particularly in Newton's formulation, looks beyond surface variety to identify underlying unity. It seeks elegant solutions to complex problems. It assumes that what appears random or chaotic actually follows deterministic patterns. These mathematical values parallel the cognitive strategies of resilient thinking, the reframing of problems as solvable, the search for unifying principles amid diversity, the belief that complexity can be mastered through proper methodology. Newton's mathematical method itself embodies principles we might associate with positive cognition. Mathematics, particularly in Newton's formulation, looks beyond surface variety to identify underlying unity. It seeks elegant solutions to complex problems. It assumes that what appears random or chaotic actually follows deterministic patterns. These mathematical values parallel the cognitive strategies of resilient thinking, the reframing of problems as solvable, the search for unifying principles amid diversity, the belief that complexity can be mastered through proper methodology. This psychological orientation extended beyond Newton's mechanical investigations to his work in optics, mathematics, and even alchemy. In each domain, he operated from the fundamental assumption that nature, despite its surface complexity, operates according to regular, intelligible principles that the human mind can discern through patient observation and mathematical reasoning. This assumption, that the universe makes sense, represents the foundational premise of what we now call the scientific mindset, but it's equally a form of cognitive optimism that Newton's search for universal order illustrates how what we term positive thinking operates at the highest intellectual levels. It's not about affirmative mantras or simplistic optimism, but about the deep cognitive conviction that reality, however chaotic it appears, conforms to intelligible patterns. This conviction doesn't merely make us feel better. It enables the kind of paradigm-shifting discoveries that literally change how humanity understands its place in the cosmos. Conflict and resilience. Newton's battles as creative fuel. Newton's career was punctuated by intense, often bitter conflicts that threatened to derail his work and legacy. Yet in each case, he demonstrated remarkable psychological resilience, transforming professional adversity into intellectual opportunity and personal slight into creative motivation. His decades-long dispute with German philosopher Gottfried Wilhelm Leibniz over the invention of calculus represents perhaps the most famous priority conflict in scientific history. Both men had independently developed versions of calculus. Newton his method of flux ions, Leibniz his differential and integral calculus. But when Leibniz published first, Newton accused him of plagiarism. The dispute escalated through letters, publications, and eventually through the Royal Society, which Newton presided over and stacked with his supporters, where a less secure individual might have withdrawn or become paralyzed by resentment. Newton channeled the conflict into renewed creative effort. He used the controversy as motivation to systematize and extend his mathematical work, producing deeper treatments of infinite series and analytical methods. The psychological dynamic here illustrates how Newton transformed negative emotion into productive energy, a pattern cognitive therapists might now call positive reappraisal or benefit finding. Newton's conflict with Robert Hooke, the brilliant but contentious curator of experiments for the Royal Society, followed a similar pattern. When Hooke criticized Newton's theory of light, Newton responded with such bitterness that he withdrew from public scientific debate for years. Yet this withdrawal wasn't merely spiteful. It allowed Newton the uninterrupted concentration to develop his masterwork, the Principia. When Hooke later claimed priority for the inverse square law of gravitation, Newton threatened to suppress the third book of the Principia, then relented but systematically removed nearly every mention of Hooke from the work. These conflicts reveal a man far from the idealized image of the dispassionate scientist. Newton could be vindictive, paranoid, and relentlessly competitive. Yet even these apparent psychological liabilities became, through Newton's peculiar alchemy, assets to his creativity. His disputes drove him to greater precision, more comprehensive documentation, and more systematic presentation of his ideas. The very obsessiveness that made him difficult personally contributed to the uncompromising rigor that made his work enduring. Later in life, as warden and then master of the Royal Mint, Newton brought the same relentless energy to combating counterfeiting that he had previously directed at scientific problems. He personally pursued counterfeiters through London's underworld, successfully prosecuting and securing executions for several. This chapter of his life might seem like a departure from science, but it reveals the same fundamental psychological pattern, the channeling of intense focus toward establishing order against chaos, whether the chaos be gravitational uncertainty or monetary instability. Newton's resilience in conflict offers a nuanced lesson in positive psychology. His approach wasn't about avoiding negative emotions or maintaining constant equanimity. Rather, it demonstrates how even negative emotions like anger, pride, and competitiveness can be harnessed toward productive ends when properly directed. Newton's mind consistently transformed opposition into motivation, criticism into refinement opportunity, and personal grievance into creative energy. This aspect of Newton's psychology has particular resonance in our contemporary culture, where conflict is often either avoided entirely or indulged destructively. Newton models a third way: the channeling of conflict's energy into creative work, the transformation of adversarial relationships into catalysts for achievement. Newtonian philosophy as hope, the psychology of a law-governed universe. Beyond his specific discoveries, Newton's greatest legacy may be the philosophical worldview that emerged from his work, a worldview that fundamentally altered humanity's psychological relationship to nature. The Newtonian universe, governed by comprehensible mathematical laws, provided the foundation for what we might call rational hope, the conviction that human reason can understand and eventually master nature's forces. Before Newton, the dominant Western worldview saw the universe as governed by divine will, magical forces, or Aristotelian essences that were qualitatively different from human understanding. This created a psychological framework of fundamental separation between human consciousness and cosmic order. Newton's demonstration that the same mathematics that describes falling apples governs planetary orbits collapsed this separation, creating what Alexander Pope famously captured in his intended epitaph: "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." This shift from mystery to comprehensibility represents one of history's most significant psychological transformations. Where medieval minds approached nature with a mixture of reverence and fear, Newton enabled what we might now call an internal locus of control, the belief that through reason and observation, humans could actively understand and predict natural phenomena rather than merely submitting to them. The Newtonian worldview's psychological impact extended far beyond scientific circles. It helped fuel the Enlightenment's optimistic belief in human progress through reason. It informed the American founding fathers' conviction that human societies could be structured according to rational principles. Thomas Jefferson specifically described Newton as one of history's three greatest men. It underpinned the Industrial Revolution's faith that nature's forces could be harnessed for human benefit. This philosophical outlook represents positive thinking at its most profound cultural level. It's not merely individual optimism, but a collective cognitive orientation, a shared belief that the universe operates according to principles that the human mind can discern and utilize. This belief doesn't guarantee success, but it makes scientific and technological progress psychologically possible by framing nature as comprehensible rather than inscrutable. Newton's own theological writings reveal how deeply this search for order permeated his thinking. He devoted years to biblical chronology and prophecy interpretation, seeking in Scripture the same mathematical regularity he found in physics. Though these theological pursuits produced little of lasting value, they demonstrate the consistency of Newton's psychological approach, the relentless application of pattern-seeking cognition across all domains of inquiry. The psychological legacy of Newtonian philosophy remains embedded in modern science's fundamental assumptions: that the universe is regular, that this regularity can be mathematically described, and that the human mind is capable of this description. These assumptions aren't self-evident truths, but rather cognitive choices, ways of framing our relationship to reality that have proven extraordinarily productive. They represent what psychologist Carol Dweck might call a growth mindset, applied to humanity's collective intellectual enterprise. Historical influence. Scientific optimism as civilizational force. The psychological framework Newton helped establish, what we might term scientific optimism, has proven one of history's most powerful civilizational forces. From the Enlightenment through the Industrial Revolution to our contemporary technological age, the Newtonian conviction that nature's laws are comprehensible and utilizable has driven unprecedented human progress. The Enlightenment thinkers who followed Newton explicitly recognized the psychological dimensions of his achievement. French philosopher François-Marie Arouet Voltaire, who attended Newton's funeral in 1727 and later popularized his work in France, saw Newton's science as liberating humanity from superstition and intellectual submission. For Voltaire and other philosophers, Newtonian physics provided the model for a new kind of society, one based on rational principles rather than traditional authority. This Newtonian optimism fueled the technological innovations of the Industrial Revolution. Inventors like James Watt and engineers like Isambard Kingdom Brunel operated from the implicit assumption that nature's forces could be understood and harnessed, an assumption that traces directly to Newton's demonstration of a law-governed universe. The resulting transformations in transportation, manufacturing, and communication dramatically improved living standards and life expectancy, creating material conditions that supported further optimism. In America, Newton's influence shaped both the practical and philosophical foundations of the new republic. Benjamin Franklin's electrical experiments explicitly followed Newtonian methodology, while Thomas Jefferson's conception of natural rights reflected the Newtonian belief in universal laws governing human society alongside physical nature. The American commitment to scientific progress and technological innovation, manifested in institutions from the patent office to land-grant universities, embodies the Newtonian psychological orientation on a civilizational scale. The 20th century's great scientific achievements, from relativity and quantum mechanics to the moon landing and digital revolution, all operate within the psychological framework Newton helped establish. Even when these developments modified or superseded Newton's specific theories, they maintained his fundamental cognitive orientation, the conviction that the universe is comprehensible, that mathematics reveals this comprehensibility, and that human reason can progressively decipher nature's laws. This historical trajectory illustrates how a particular cognitive approach, what we're calling positive thinking in its most sophisticated form, can scale from individual psychology to civilizational force. Newton's personal ability to find order in chaos became, through his work, humanity's collective conviction that chaos could be ordered. His individual resilience became civilization's progress. The psychological legacy becomes particularly clear when we contrast societies that embraced the Newtonian worldview with those that didn't. While Europe and America experienced scientific and industrial revolutions, other sophisticated cultures with advanced mathematics and technology, such as China and the Islamic world, failed to achieve comparable sustained progress, arguably because they lacked the psychological framework that saw nature as systematically comprehensible and improvable through methodical investigation. Newton's shadow, the limits and lessons of his psychology. For all his psychological strengths, Newton was neither perfectly balanced nor universally admirable. His example becomes most instructive precisely where it reveals the complexities and potential costs of his cognitive approach. Examining Newton's psychological limitations helps us develop a more nuanced understanding of positive thinking's proper role in intellectual and personal life. That Newton's capacity for intense focus bordered on obsession, sometimes with questionable pursuits. He devoted years to alchemical experiments, seeking the philosopher's stone that would transmute base metals into gold. He immersed himself in theological calculations, aimed at predicting Christ's second coming. While these activities reflected his consistent pattern-seeking mentality, they also demonstrate how the same cognitive approach that produces revolutionary insight can also lead down unproductive paths when applied without adequate empirical constraints. Newton's personal relationships suffered from his psychological peculiarities. He never married, formed few deep friendships, and maintained strained relationships with most family members. His notorious conflicts with Hooke, Leibniz, and others reveal a man who could be paranoid, vindictive, and unable to accept criticism. The same single-mindedness that enabled his intellectual achievements made him difficult personally and professionally. Later in life, Newton suffered what would likely now be diagnosed as a nervous breakdown, experiencing insomnia, loss of appetite, and paranoia about his friends and associates. In 1693, he wrote letters accusing philosopher John Locke of endeavoring to embroil me with woemen, and complaining that he had been upon the brink of misery because of unnamed enemies. This episode reminds us that even history's most formidable minds have psychological breaking points. These aspects of Newton's psychology provide important correctives to any simplistic celebration of positive thinking. They remind us that cognitive strengths often come with corresponding vulnerabilities. The same mental patterns that produce breakthrough thinking can also lead to dead ends. Intellectual achievement doesn't necessarily correlate with personal happiness or relational health. Even the most resilient minds have limits, yet Newton's psychological challenges also complete our understanding of his achievement. His ability to produce revolutionary work despite, or sometimes because of, his psychological peculiarities makes his example more humanly accessible. We don't need perfect mental health or balanced personalities to think positively in the constructive sense we've described. Newton demonstrates that cognitive resilience can coexist with personal difficulty, that the capacity to find order in external chaos can persist even when internal chaos remains unresolved. Most importantly, Newton's example suggests that what we call positive thinking works best not as a state of constant equanimity, but as a practiced cognitive orientation, one that can be maintained even amid personal struggle, relational difficulty, and psychological vulnerability. Newton wasn't psychologically invulnerable. He was cognitively resilient despite his vulnerabilities. This distinction makes his example more applicable to our imperfect lives. Conclusion: Newton's cognitive legacy for our time. As we confront our own era's cascading crises, climate disruption, political polarization, pandemic recovery, technological dislocation, Newton's example offers not solutions to specific problems, but a model of cognitive approach. His life demonstrates how the human mind can maintain creative agency when circumstances seem designed to produce despair, how order can be discerned amid apparent chaos, and how limitation can be transformed into advantage. The psychological principles we can extract from Newton's example include the pattern-seeking imperative. Newton's mind consistently looked for regularities behind surface irregularities, mathematical order behind phenomenological complexity. This orientation, which we might now call meaning-making, represents perhaps the most fundamental form of positive cognition, the transformation of obstacle into opportunity. Throughout his life, Newton converted limitations into advantages, his isolation into focus, his conflicts into motivation, his pandemic retreat into creative ferment, the channeling of negative emotion into productive work. Newton didn't avoid difficult emotions. He harnessed their energy toward intellectual ends, transforming anger, pride, and competitiveness into creative fuel, the maintenance of fundamental cognitive optimism. Beneath all his work lay the conviction that the universe is comprehensible, that mathematics can describe this comprehensibility, and that the human mind is capable of this description. The integration of apparent chaos into systematic understanding. Newton's greatest achievements involved finding unifying principles behind diverse phenomena, the same gravity governing apples and moons, the same mathematics describing change across domains. These cognitive habits represent what we might call positive thinking at its most sophisticated and powerful. They have little to do with the simplistic affirmations sometimes associated with the term, and everything to do with the fundamental orientation of a mind determined to find coherence, opportunity, and creative possibility regardless of circumstances. In our current historical moment, where problems often appear overwhelmingly complex, where political and environmental systems seem increasingly unstable, where technological change accelerates beyond our capacity to adapt, Newton's cognitive example offers a way forward. It suggests that the most powerful response to chaos isn't denial or despair, but the determined search for underlying order. It demonstrates that human consciousness can remain the active source of meaning even when external conditions threaten meaning's collapse. That Newton's universe was governed by gravity, the invisible force that brings order to cosmic motion. His life was governed by what we might call the gravity of spirit, the cognitive force that brings order to mental chaos. As we navigate our own tumultuous times, this gravity of spirit may prove as essential to our survival as understanding physical gravity has been to our technological progress. Newton's greatest legacy may ultimately be not the specific laws he discovered, but the cognitive example he set, the demonstration that the human mind, properly oriented, can find light even in history's darkest nights. I truly hope these ideas will inspire you on your own path of discovery. If you know someone who would find this perspective valuable, please share this video with them. And to make sure you don't miss what's next, subscribe and join me for the upcoming videos.